Alright, let's take a look at this example. Let's try to find the LCM of 15 and 24. So in order to find the LCM, you need to do a prime factorization on both 15 and 24. And prime factorization is the key thing to tackle the LCD LCM problems. So first of all, let's factor 15, right? So 15, write down 15, and we're gonna construct a tree diagram. And let's take a look at the smallest prime number that goes into 15. First of all, 2 is the smallest prime number, but 2 doesn't go into 15. Then we move on to next prime number, which is 3. 3 is the prime number that goes into 15. 3 going into 15 5 times. Now both 3 and 5, both factors are prime numbers, so we basically complete the prime factorization. So 15 is equal to 3 times 5. Both factors are prime numbers. And let's take a look at 24. So 24. And the smallest prime number going to 24 will be 2. 2 going to 24 12 times. However, 12 is not a prime number yet, so we're gonna keep breaking down 12. So the smallest prime number going to 12 is 2 again. 2 going to 12 will be 6 times. 2 is a prime number, but 6 is not, so we have to keep breaking down 6. And the smallest prime number going to 6 will be 2. Then the remaining factor is 3. So the 24 is equal to 2 times 2 times 2 times 3. And we normally write a repetitive factors as exponents, so we get a 2 times 2 times 2 becomes 2 to the third times 3. Now the LCM is determined by the prime factorization. So what we do is we look at each individual factors, and we start with 2. 2 is the factor appear on 24, and we take the highest exponents, so 2 cubed. And both prime factorization include 3, so we include 3. Also 5 is a part of the factor for 15, so we also include 5. So eventually we end up with 8 times 3 times 5. 8 times 3 is 24. 24 times 5, 120. So the LCM is 120. Alright, so that's the example number 1. And let's take a look at a very similar example, which is example number 2. Now we have 3 numbers, 12, 18, and 27. And pretty much we perform the same procedure, right? We do the prime factorization for 12, 18, and 27. We start with 12. So smallest prime number that goes into 12 will be 2. 2 is a prime number, put in the circle that. Then the remaining factor will be 6. 6 is not a prime number yet. We have to keep breaking down this. So the smallest prime number going to 6 will be 2. 2 going to 6 3 times. Alright, so we take care of the 12 now. So 12 equals to 2 times 2 times 3, which is 2 squared, times 3. We always write it in a simplified form. Now let's take a look at 18. The smallest prime number going to 18 will be 2. 2 going to 18, 9 times. Now 9 is not a prime number yet, so we gotta take the smallest prime number and make it go into 9. So the smallest prime number going to 9 will be 3. 3 going to 9 3 times. So 18 is equal to 2 times 3 times 3. So we have 2 times 3 squared. The very last one we have to break down is 27. So for 27, the smallest prime number going to 27 will be 3. 3 going to 27 9 times. Now we break down 9 as 3 times 3. Now 27 is equals to 3 times 3 times 3 equals to 3 to the third. So the LCM, both the 12 and the 18 has a factor of 2. We take it 2 and we use the highest exponent or higher exponent. In this case it would be 2 to the second. And in terms of 3, each prime factorization includes a factor of 3, and the 27 has a highest exponent, which is third cube. So we have 3 to the third. Then we end up with 2 squared, which is 4. 3 squared, 3 cube will be 27. So 4 times 27 is going to be 108. So LCM will be 108. So every time you have a LCD or LCM problem, prime factorization is one of the most effective way to find the LCM or LCD. Alright, let's take a look at this example. Let's try to write a following improper fraction as mixed numbers. And take a look at the first one, which is 56 over 3. So basically, anytime when you try to convert the improper fraction to mixed numbers, you just gotta do the division, right? So you gotta write 56 over 3. And then just for a regular division procedure, so 3 going to 5, which is 1 times 3 is gonna be 3. Subtract it, you get 2. Bring down the 6, we have 26. And 3 going to 26 will be 8 times. 8 times 3 is 24. So we have a remainder of 2. So basically the answer for this will be 50 over 3 in terms of mixed number will be 18. That's whole number part, and then write the remainder 2 over divisor 3. So that's your answer for first question. Second question, it's 49 divided by 4. So 4 going to 4, 1 times. 1 times 4 is 4. I'll bring that to 9. So 4 going to 9, 2 times. 2 times 4 is 8. Subtract it, you get a remainder of 1. So the answer for 49 over 4 is going to be 12. Remainder 1 over divisor 4. The very last one is 63 over 21. Actually, it's 21 going to 63 3 times. 3 times 21 is 63. So that's no remainder. So in this case, you're just gonna end up with 3. Alright, so anytime when you convert an improper fraction to mixed numbers, just follow the division process. And if you have a remainder, write a remainder over divisor as your fraction, and on the left hand side put a whole number.